The next idea that I want to introduce to you is that of distributions. A distribution is a picture of how our data look. We have already seen an example of a distribution when we looked at a bar graph. So what I'd like to do now is throw you in the deep end of the pool to see if you can figure out how a histogram would be created with simple frequency values. In the course notes, I have provided you with an x-axis and a y-axis. The scores, or x values, are going to go on the x-axis. That makes sense, right? The frequencies will be plotted on the y-axis. I know this is something we have not practiced yet, but I'd like you to give it your best shot. It's probably something you've already learned in a math class, and it's okay if you get it wrong. But in attempting it, you will figure out what you need to know. So right now, pause the video, try creating the histogram with dataset 2, and then come right back. Your bar graph will not look as clean as this one that I created in SPSS, but you should have approximately the same distribution. If you made a mistake, that's all right. See if you can figure out where you went wrong. And if you were able to create something that looks roughly like this, congratulations. You have now made a distribution. A distribution is a picture of your data. It is important to understand what we mean by distribution. For instance, if we are talking about human beings, we could create a distribution of qualities with these people. Let me use this illustration to see if I can make the point more clearly. The variable of interest is height, and so we get a group of college students to assemble one morning on the football field. We have rows of signs that run from 5'0" all the way up to 6'6". For this illustration, we assume that everyone in our sample knows their own height. That is an assumption, but most people tend to know how tall they are, so we are assuming that there is no measurement error in our data. That is an assumption that can get us into trouble sometimes, so we have to be clear that we are making an assumption of no measurement error and remind ourselves of that assumption so that we don't go too wrong. We ask people to stand in a row behind the sign that best represents their height. You will notice that we have conveniently asked our subjects to wear different colored shirts. All of the men are wearing black shirts and all of the women are wearing white shirts. This will help us see the distribution of scores quite nicely. Once everyone has taken their place on the football field, we can begin to learn something about our distribution. For instance, some rows are longer than other rows. Any idea why some rows are longer? It is because there are more people in that row. If we just look at the males, those wearing the black shirts, we see that the longest row is also the middle of the data. The longest row is 5'10". That middle row is our measure of central tendency. It is where the center of the data tend to be, and it has the greatest frequency. When we look at the women, those wearing white shirts, we see that there are more women in the row of 5'4". So if we had all of the men come off the field and then had all of the ladies step forward so the first person in the row was standing on the sideline, we would see that women have their own distribution with their own measure of central tendency. So what we really have are overlapping distributions, with an average height for males and an average height for females. We could describe this distribution as bimodal. We have two most frequently occurring scores, one for males and one for females. We can also see other features of the distribution. For instance, we can spot outliers. Notice the gap between the row for 6'2" and the one person standing in row 6'6". The person who is 6'6" is an outlier. His score lies far away from the typical score. Now, let us create a line of the distribution. Now, we could do this with all of the participants, both male and female, on the field. But let's imagine that we asked all of the ladies to step off of the football field and left just the guys standing there. We take a long rope and we walk behind our subjects, asking the last person in each row to hold onto this rope as we stretch it from one end of the field to the other. Now we go up to the press box so that we can look down on the field and see the shape of the rope. Looking down at that rope on the field, we see the shape of the distribution of heights. The last guy in the row is holding the rope. From the press box, it might look a little like this. We have rows of guys and a rope at the end of each row. Now we ask them to set down the rope on the field, and then ask everyone to leave the field. The remaining rope would look a little like this. Looking down from the press box at that rope on the field, we see the shape of the distribution of height. The further the rope is from the sideline, the more people there were in that row. In rows with greater frequency, the rope is further from the sideline. In rows with fewer people, the rope will be closer to the sideline. Creating a picture of our data using a bar graph, histogram, or line graph can tell us some very important things about what is going on with our numbers.